And just to recap, we started with a video the other day, is that correct? And then from there, on the video, we agreed that we're talking about opposite numbers. That's why negative 7 plus 7 equal to 0. And we said from now on, those were going to be called zero pairs. Zero pairs. And when they are combined together, they make ground zero. Is that correct? All right. From there, I also did an intro of the lesson, the objective. And I said, I can define and represent integers using integers, tiles, and zero pairs. Let's read it together. 1, 2, 3. I can define and represent integers using integer tiles and zero pairs. So by now, check this out. By now you should know the main concepts of this lesson. Is that correct? Yep. So if I was to ask you these questions, what is the concept for today? What are we doing? Think about it. And tell your neighbor what the concepts are for today and what we're doing with it. Okay, yes, you're right. They are integers and zero pairs. And what are we doing? We're defining and representing those. Okay? So then we got started with that. We also said, okay, well, let's clarify what integers are. And I gave you guys a Freyer model. We filled that in. On the Freyer model, we got a definition. We said that integers are whole numbers with their opposites. I gave you guys examples, non-examples. And then from there, we said if your BFF was not here, what would be the most important thing you would tell them about integers? Is that they are what? Whole numbers. And they don't have fractions or decimals. And they have their opposites, right? Okay, so we're clear. Are we there? Okay, so now, at that point, this is where we're going. I introduced the properties, didn't I? Okay, so check this out. The properties that I was talking about is the additive inverse property. Don't copy this, I'm just going to recap, okay? The additive inverse property says that any number and its opposite is equal to 0. Didn't I show that using that video, right? Its number with the number with its opposite equal to 0. And it is written like this: a plus negative a equals 0. And what does that look like with numbers? 7 plus negative 7 equal to 0. Negative 15 plus 15 equal to 0. And then how about negative 2500 and 2500? 0. And all that is the additive inverse property. But I said from now on, instead of calling it the additive inverse property, we're going to call those what? Zero pairs. Zero pairs. So we got that, right? Okay. The second property that I wanted to address was the following. The second property is the identity property of addition. Identity property of addition. What does that say? It says that if you add 0 to any number, at the end, we're going to get the number as a result. So check this out. 0 plus 7, what does that give us? 7. Also, negative 10 plus 0 is negative 10. Same thing with 1,000 plus 0 is 1,000. That's using the identity property of addition. Why is it called the identity property of addition? Because notice here, we have 0 plus the number. Don't we get as a result the identical number? Same here, the identical number. Identical number. That's why it's called the identity property of addition, because we're adding. Are we there so far? All right, so let's get started. Example number 1. Underneath your Freyer model, the Freyer model from your notes, I want you to copy this down. Example number 1. Oops, sorry. Example number 1. Underneath your Freyer model, underneath the little box, I want you to write. So you're on your paper, you have this. Underneath, you're going to write example 1 and copy that down. It says, example 1, show a zero pair using algebra tiles, negative 7 plus 7. Copy it first. Okay. So It says, show a zero pair using algebra tiles, -7 plus 7. I gave certain rows baggies with tiles. So what I need you to do, everybody look up. This row, get together with that row. You're going to be sharing tiles. You guys are partners. This row, get together with that row. You're going to be sharing tiles. You guys are partners. This row with that row, you're going to be sharing tiles, and you guys are partners. And you guys are alone. Just kidding. You came up with Hyan, and you came up with Alpha Delta, and like these are. Stop. Get together with it. And you have the tiles right there, right? This. All right. Get your desks together, please. Move your rows, please. Hurry up. All right, here we go. So, check this out. This is what I want you to do. Using your tiles, we're going to represent -7 first. So you need how many negatives? So you do 1, 2, 3, 4, 5, 6, 7. Get those tiles in front of you. You have those in there in that baggie. And underneath that, we're going to write the positives. How many positives are we talking about? 7. So we got 1, 2, 3, 4, 5, 6, 7. So that's how you should have them on your table. And also, once you have them on your table like this, the way I'm laying them out, I want you to copy this picture on your paper. If you have your colored pens, do the same. Use the same colors. So, -7 and +7, you circle this. And you cross it out because it's a what? 0. So therefore, check this out. Everybody look up. Look up. -7 plus 7 equal to 0. And if we draw our ground zero method, check this out. It should look like this. -7 and +7. Copy that, please. Does everybody see it? The hole in the dirt? Yeah. Okay, copy that, please. Okay, so far so good, right? All right, underneath that, I want you to write example number 2 if it fits. If it doesn't fit, turn your paper over and do it in the back. Here we go, example number 2. Example 2. It says, show a zero pair using algebra tiles, -3 plus 3. -3 plus 3. Get those tiles in front of you, show the zero pair. Once you talk it over with your neighbor and you agree, draw your picture on your paper. Go. And also draw your ground zero method. Okay, so for this one, you should have gotten 3 negatives, 3 negative tiles, 1, 2, 3, and 3 positive tiles, 1, 2, 3. You also drew this picture on your paper, right? You circled your zero pair, you crossed it out, and you did -3 plus 3 equals 0 because it's a zero pair. Your ground zero picture should look something like this, -3 and +3. So far so good? Example number 3, underneath that, copy this next one. If it doesn't fit, once again, you may continue in the back. Here we go. So example number 3. Copy this one. Show a zero pair using algebra tiles, -10 plus 10. Copy that. Show me with your tiles. Draw your picture on your paper. Cross it out. And draw your ground zero method. Okay, let's see. So for this one, fairly simple. You should have in front of you 10 negative tiles. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 positive tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since they are a zero pair, I circle all of those, cross them out, and we write -10 plus 10 equals 0. In our ground zero method, -10 plus 10. Are we clear up to right there? Piece of cake? All right. So here goes the next part. Let's kick it up a notch. Yes? Example number 4. Copy this down, please. It says, example number 4. Represent -1 using algebra tiles, okay, and 0 pairs. Once again, represent -1 using algebra tiles and 0 pairs. Copy that. And then I want you to talk it over with your neighbor and see how you're going to do that with your tiles. Think about it. You have to use your tiles, and you also have to use 0 pairs. But at the end, it has to represent what? -1. Think it over, talk it over, agree on what you come up with. Then I'll call on someone. Lucia, what do you have in front of you? How many negative tiles and how many positive tiles? Let's see. -6. 1, 2, 3, 4, 5, 6. And how many positives? 5 positives. 1, 2, 3, 4, 5. Let's see if he's correct. Do we see a 0 pair here? These 5 negatives with 5 positives. They cross out, and we're left with what? -1. Does this represent -1? Okay, so let me write it in numbers. Everybody look up, please. How many negatives? 6, so that's -6 plus 5, and that is equal to -1. And my ground zero method, I do this, -6 and +5. Copy that, please. All right, so check this out. And how this works, everybody look up. Look at the 0 ground method. I have a hole that is 6 feet deep. But how much dirt do I have? 5. So if I fill it, will it fill all the way to the rim? No, we still have hole left. Is that correct? So that's why we end up with -1. That's how that works. Lucia, pick somebody, please, to see what they got. Aidan, what did you guys write? How many negatives and how many positives do you have in front of you? 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. 7 positives. 1, 2, 3, 4, 5, 6, 7. And if we eliminate our 0 pair, does this represent -1? Yes, do you agree with that? Yeah, right? In numbers, it's -8 and +7, and that is equal to -1. And here's our ground zero, -8 and +7. Copy that one also, please. And you should have your own example also. So you should have 3 different examples for this example number 4. Example 5, copy this. It says, represent +4 using algebra tiles and 0 pairs. So now it's +4, but I want you to use the tiles and 0 pairs. Talk it over with your neighbor, get your tiles in front of you, get to work, and copy that on your paper. Go. All right, let's see what we got. Aidan, pick someone. Sabrina, what did your team get in front of you? Let's see, tell me how many negative tiles, how many positive tiles. 1 negative. 5 positives. 1, 2, 3, 4, 5. We eliminate the 0 pair. Do you guys see it right here? Okay, so in numbers, this looks like this. -1 plus +5 equals 4. And my ground zero method should look something like this, -1 and 5. The reason I made the hole a little bit smaller so that you guys can see that there's too much dirt, and like you'll have dirt left over. Does that make sense? Okay. Yeah, does everybody agree with that? Yeah, copy that one, please. And Sabrina, pick someone so I can get another one. Francisco, what did you guys get? 2 negative, 6 positive. 1, 2, 3, 4, 5, 6. We eliminate the 0 pair. And this could be written as negative 2 plus 6 equals positive 4. And our ground 0 should look something like this. Negative 2 and positive 6. Copy that, and do you guys agree with that one? Yeah, that's also representing positive 4. Now check this out. Now, the neat part about using properties and concepts is that we can use those to add integers. We've been adding integers, guys. Check this out. Pens down, eyes up here. If we look up, look at this. Negative 1 plus 5 is 4. Negative 2 plus 6 is 4. Also on the previous one, check this out. Negative 6 plus 5, that's negative 1. And negative 8 plus 7, that's negative 1. We've been adding positive and negative numbers just using the additive inverse property. Ain't that cool? Pretty cool, right? So now check this out. So for this next one, for this next one, example number 6, this is the last one of these. Copy that one. And it says represent negative 6 using algebra tiles and 0 pairs. This is just so that you can have enough practice of these. And make sure you have your tiles in front of you. Draw your picture. And agree on what you come up with. Go. All right. So it says represent negative 6 using algebra tiles and 0 pairs. Who went last? Okay, pick someone. Francisco. Priscilla. Let's see. Give us your model. What'd you get? 5 negative? 12. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 positives. 1, 2, 3, 4, 5, 6. Here's my 0 pairs. And this could be written as negative 12 plus positive 6. That is equal to negative 6. In our ground method, 0 ground method, like this. This is negative 12 and positive 6. Does yours look something like that? Yeah? Hands if you agree with that. Okay, copy that one. The only example I'm going to take for this one. And you should have 2, your own and this one. Okay, so I think pretty much we got it, right? Okay, so now let's move on and let's crank it up a notch. Now, like I said this year, I'm not interested just in you doing the computation and the work. I want to make sure you understand it. So for this next one, I want you guys to copy this, but also think about the questions and talk it over with your neighbor because I want a sentence as an answer. Yes, I know. Even though it's math, we're going to be writing. So let's think about it. Here we go. Example number 7. Copy that one. It says, show me negative 6 plus 9 using algebra tiles and 0 pairs. What amount does that represent and why? Once again, example number 7. Show me negative 6 plus 9 using algebra tiles and 0 pairs. What amount does that represent and why? Okay, now when you write your sentence, think about the 2 major concepts that we addressed in our objective. What are the 2 major concepts? Tell your neighbor. Integers and 0 pairs. Make sure you use that terminology in your sentence. See if you can use those terms in your sentence. All right? I'll give you guys some time. Go. Who went last? Priscilla, pick someone, please. Vivian. Let's see. Read us your sentence, please. It represents positive 3 because when you get your 0 pairs, You cancel them, and you get positive 3. Okay, that's close, but not quite specific, right? If somebody was to walk in and you were to say that and give them this, they might not understand. So you need to be more specific with the 0 pairs. Who has something different? Let's see, right here. He said the amount of negative 6 plus 9 equals 3, positive, right? Because the negative 6 plus what? The 6 0 pair gets eliminated, and you end up with 3 integer, or the integer 3 positive. Does that make a little bit more sense? Yes, remember, try and incorporate your terminology, your integers and 0 pairs in it, all right? And one last one, Gus. Okay, and once again, he said something similar, and he said negative 6 plus 9 equals 3 because negative 6 plus positive 6 cancel, and that leaves you with 3 positive, which is the integer 3. Okay, I'll take any of those, and for your drawing, you should have done 1, 2, 3, 4, 5, 6, and then you got 1, 2, 3, 4, 5, 6, 7, 8, 9. You circled your 0 pair. They cancel, and we're left with positive 3, and in numbers, it would be negative 6 plus 9 equals 3, and your ground 0 method, negative 6 and positive 9. Hands, if you got something similar to that, okay? So now, like I said, the hard part in some of my homework is going to be the vocalizing the answer to the question, okay? So, to finalize this, check this out. Who sees that this is the additive inverse property, the 0 pairs? Does everybody see that? However, what was the other property? The identity property of addition. Remember, it said 0 plus any number equals to that number. So look at this one. Let's look at some of the examples that we did earlier. Check this out. Look at this one. Oh, sorry. Look at this one. Isn't this 0? So this is 0 plus what? 4. And what did we end up at the end with? 4. Isn't this 0? Yes, plus 4 is also 4. So does it matter which amount of 0 pairs we put in for 0? No, the property still works. Does that make sense? All right. So to finalize this, copy this homework down if you have a blank sheet of paper. Homework. It's only 4 problems, but it has questions, so therefore I need sentences for answers. Number 1, in your own words, define 0 pairs or the additive inverse property. Number 2, in your own words, define the identity property of addition. Number 3, represent a 0 pair using tiles and describe it in your own words. And number 4, represent negative 7 plus 12 using tiles and 0 pairs. Describe your number in your own words. Okay? So, copy that. That's going to be your homework for tonight. As soon as you copy it, make sure you put all my tiles back in the baggies, turn them in, and enjoy your homework. I'll see you guys tomorrow.